Hi, this video is about incrementing and decrementing. The Intel 8080 or 8085 and Zilog Z80 have specific commands for this task. Every CPU register can be incremented or decremented by 1. The command is increment register, then you specify a register. Let's take B, increment it 3 times. And the decrement command is dc.o.p.r. Decrementing B again 3 times. So the register B is FF. If we increment it by 1, it will turn 0. You see here the 0 flag is set to 1 because B turned 0. Sign flag is 0 because it's a positive number. Auxiliary carry flag, we will cover that in another chapter when we cover BCD numbers. The parity flag is also set because there are 0 1 bits set. I've covered the flags in previous chapters. But don't forget, the code should also run on the Zilog CPU. The P flag is not set the same way on the Z80 than on the Intel, at least for arithmetic operations. With logical operations, that's not a problem. Okay, incrementing by 1, 0 flag is now 0, parity is 0 because there's 1 bit set. Decrementing, 0 flag is again set, and the sign flag is set just to mention it could be a negative number. You can use the following registers: A, B, C, D, E, H, L, and also the M register. Let's cover just one example with the M register. I mean, HL should point to address F0. Increment register M, increment register M, increment register M, decrement register M, decrement register M. So here's the memory address. Setting HL to the memory address, incrementing the memory by 1. The flags are also set. You can also increment or decrement 16-bit registers. That's increment extended. For example, B or D or H, even the stack pointer, and also decrement B, D, H, and the stack pointer. So incrementing extended register BC, BC will be 0 here. BC is 0 now, but the flag register is not modified. That means with every 16-bit increment or decrement command, the flag register is not set. So incrementing D, E, the stack pointer, HL is incremented, stack pointer, after FF it turns to 0, decrement, 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 and stack pointer is also decremented. Stay tuned if you want to see the corresponding commands for the Z80. Otherwise, see you in the next video where we'll cover the compares, jumps and calls. Bye bye. The command to increment is inc, increment, and then you specify the register. Let's take B for example. Incrementing it 3 times. And then decrement it, DEC, 3 times. So B will be incremented by 1. After FF it will get 0. B is 0. Sign flag is 0 because it's a positive number. 0 flag is 1 because B is 0. The hull flag or the auxiliary carrier flag, we will cover that in a BCD number video. And the parity flag is also set, but it's not set like in the Intel 8080 or 8085. It will always be 0 except when the previous value was 7F in hexadecimal or 127 in decimal. Incrementing again. 0 flag is now 0 because B is 1. And to decrementing, 0 flag turns 1 again. FF, now the sign flag is set to show that it could be a negative number. You can use the following registers: A, B, C, D, E, H, L, memory address over HL, and index register IX, and index register IY. Let's do a quick example with HL. Memory address F0. Incrementing the memory address at address HL, and also decrementing it. Okay. So let me specify here, for example, 7F, incrementing it, or first we're loading HL with a memory address F0, incrementing the memory by 1, memory is incremented by 1, sign flag is 1 because it could be a negative number, and parity flag is also 1 because it has changed from 7F. It's in this case it's an overflow flag. Incrementing by 1 again. Parity flag went 0. Decrementing and decrementing again. Parity flag is 1 because the 7th bit has been cleared. there's also a way to increment or decrement 16-bit registers. So for example, you could say increment BC, or increment DE, increment HL, increment the stack pointer, or increment the IX register, and also increment the IY register. And the same goes for decrement. So it's always a 1-byte command, except for the increment or decrement IX or IY. That's a 2-byte command. So incrementing BC will be set to 0. And you can see the flag register is not modified with 16-bit increment or decrement commands. The E, HL, stack pointer, IX, IY, and decrementing BC, and the flag register is never modified. There's one command left. That's a decrement jump on 0, which I will explain in the next video, where I will cover the compares, jumps and calls. See you. Bye bye.